Hello, everyone, and welcome to this special training with Adam Rackis. We're going to be exploring the depths of TypeScript. He's going to show us some really awesome stuff. If you don't know Adam, Adam is software engineer, senior software engineer over at Spotify, and an awesome Twitter personality. You can find him at Adam Rackis on Twitter. Adam, hello. Thank you for joining us today.
Hello, thank you for having me.
Yeah. So, what are we going to be learning today from you?
So this is sort of a distillation of some of my more favorite parts of the render ATL TypeScript workshop that I did that we're going to go over here.
Amazing. Well, take us away.
All right, so I'm going to speed run the introduction to TypeScript. I'm assuming the people seeing this are already somewhat familiar with it for the most part, but there's one aspect of TypeScript that I want to cover, and that is that TypeScript is structurally typed. I hope people are at least somewhat familiar with that idea. If not, I'm going to give a brief introduction to that. Let's say that we have some type called foo, and if you're wondering what that export default null is, don't worry about it at all. You need some export or import, otherwise TypeScript's just going to pretend that this is a global file and these are all global variables, and we don't want that. But let's say that we have some type called foo. If we say let f is a foo, and then you set it equal to the right thing, that of course works. But the reason why it works is because this object matches the same shape as foo. And that seems kind of obvious. Like, what else could it be? But where it becomes interesting is this applies always to everything. If I have some class called foo, and it's basically the same thing. It has a number. As far as TypeScript is concerned, these are basically the same type, or at least they're interchangeable. So this f that I declared of type foo, I can set it equal to a new foo2, and that's also fine because these have the same shape. They have the same structure. That's what we say when we mean that things are structurally typed. So in other languages like Java or C#, if you say that something is of the type of some class, that means you can only assign it to things that are that class, instances of that class, or instances of child classes that inherit from that. But in TypeScript, that's not the case. TypeScript only cares about the structure of things. So even though I declared this to be of this class, I can just assign it to just a plain JavaScript object, and TypeScript is completely fine with that. So that structural typing is central to a lot of what TypeScript does. And that's the one sort of introductory thing that I want to cover because we're going to see it again and again and again. And there'll be a few twists here and there with how structural typing rears its head. Before I get started, feel free to hit the chat up anytime. If people have questions, I would be happy to answer them. And with that, I'm going to start the first actual section that I have planned here. And we're going to talk about generics. And again, I'm assuming the people here have used generics a bit. This might be a bit of a review or refresher. You might not learn too much from this section, but I think it's a good thing to go over. And I like talking about generics sort of from the ground up, going from 0 to 100, just to sort of really nail down what they are and what they're for and what they do. So with that, let's just pretend that we want to write some sort of function that filters an array. And of course, arrays come built in with a filter function, but we're just going to ignore that. And we're going to write it ourselves just to sort of play with the types and to see where generics sort of help out and what they unlock. So we're going to say we have this filter untyped function that takes an array of any's for now, and then it's going to take a test, right? We need to pass in a test function that filters it. So we'll say test, and that takes an item for now of any, and the function returns Boolean. And this function returns a new array, of course, the filtered array. And here's our result. And we'll just loop through the array if test, I'm going to call the test function with each member of the original array, and if it passes the test, say result.push val return result. And again, this is built into arrays. We don't need to rewrite it, but just for fun. So this is fine and this works. The problem is it's all untyped. Everything is any, and we want to type this. We want to run this with, say, an array of numbers, and then we want to force us to return an array of numbers back, and the test function should take a number in. And so let's write a version. Whoops, let's write a version for numbers. And you probably know where this is headed. So just bear with me for a moment. So this is going to be the same function that we just wrote, except we want to replace all these any's with number. And we just want to do it in the new function. So that one's going to become a number. That's going to become a number. It's going to return a number array, and our result is going to be a number array. And that should be fine. We can say let numbers and we can say filter numbers and we'll just grab the even ones. We'll say this is the even numbers. And so the function will pass in num modulo 2 and 0. And that should be what we want. And so this is declared as a number array, and it works fine. But what if we want to filter strings? So we would do the same thing, and we would do a find and replace. And you get where I'm headed with this. And that's what generics allow. What we want is, oh, and even if we were to write this out for numbers and strings and Booleans, there's an infinite number of types. Any user-defined type, any object type, we still want to work with this. And so let's write a version of this that works for any type. Let's just call this new version filter. And we want to parameterize this function based on a type. So we already have parameters to this function. But we want a new parameter to this function, a special parameter that's a type. And we're going to pass it like that. And so now, in addition to taking traditional parameters like this, TypeScript is now telling this function to also accept a special kind of parameter that's a type parameter. And we can use that type parameter anywhere we want. We can use it in the arguments list. So now the type of array this takes in is a T array. And this function still returns Boolean, but the argument to that function is now a T. And we're going to say const result. And now this is a T array. And this part is identical. So I'm just going to copy paste that. And now return result. And that's cool. And there's one other intro to JavaScript part that I didn't, intro to TypeScript part. TypeScript is very, very good at inferring types. So you won't normally go through the effort of typing colon number array and then assign it to a number array. TypeScript's pretty smart. It'll infer the type for you. It's still a number array. You'll see me do this a lot. It's just to make things very, very clear so you know exactly what's going on. So just be aware that in real life, you will normally rely on type inference a lot. It's funny. Yeah, Boolean or Bool, depending on what language it is. There's a lot of different varieties. All right. Let me make sure I covered everything I wanted to. And lastly, classes can be generic as well. We can pass. Oh, so let's actually put this function to good use now. We have our numbers array like before. And let's say So we want to call this filter function that we just wrote. So two things we need to do. We need to provide this t parameter. It's a type parameter now. It's not a traditional function parameter. It's a type parameter. So we can pass that like this if we want to. And again, some of you might be looking at this side eye. For now, we can explicitly pass this type parameter to the function like that. TypeScript's yelling at me because we need to pass regular parameters too. So we'll pass numbers and you'll see it yell like that sometimes if the variable's unused. I should have tried to shut that off before I started. So this works, and this is valid. If you look at this and you think about it, this filter function up here, it takes a type parameter t, but the regular parameters directly use t in a number of ways. And so if TypeScript were smart, it could see that this is kind of redundant. Like I'm passing in a numbers array here. And so if this is an array of numbers, well, then it should be able to work backwards and infer that t is of type number. And TypeScript is smart, and you can do that just fine. And also note that we don't have to type the argument to this function because TypeScript, again, can infer that pretty clearly. So we know one way or another that this is filter of type t, and so this function takes a number. And if we were to try and type it, that's fine. You can give it an explicit type. If you really want to give it the wrong type, TypeScript's going to yell at you and say, hey, this isn't lining up. This is a numbers array, so this should be a number, and so on. Okay. Lastly, the last sort of introduction here is that classes can also take generic arguments. So we can go back to our foo. There's some foo up in. Okay. So we can have a class foo, and it can take some type parameters if we want. These are unused and useless so far. Let's say we have some properties. Property 1 is T1, property 2 is T2. TypeScript's yelling at us. So if you remember before I whipped up that class and I gave it a default value, we can't give it a default value here. So TypeScript's gonna be like, hey, you need to initialize these properties somehow. So we will create a constructor function. And let's see, val1 is a T1, val2 is a T2, and we need to initialize property 1 and property 2, and we'll do that now. Okay, so I typed a lot. There's nothing interesting happening here. So this is a class. It's got a few properties, and it's got some type arguments as well, just like before with the function. And the constructor is taking some parameters that are typed against those type parameters we just set up. And like before, we can use the class, and we will pass in arguments for those type parameters. We'll say number and string. And now we need to invoke our constructor. And look at that, TypeScript is like, okay, you said number for the first, for T1. That means the first argument to your constructor is going to be a number, and it is lined up number. TypeScript's telling us that. And we told TypeScript that T2 was going to be a string, and TypeScript is already like, hey, okay, val2 is a string. So we'll pass a number and a string, and life is good. Again, though, you might think to yourself, well, this is redundant. If I'm passing a number and a string, TypeScript should be able to look at the constructor and sort of reverse generate what those types are. And TypeScript, again, is smart. And so we can just kill off the explicit generic values and rely on TypeScript to infer them. So the point of that is just know that you can, like 9 times out of 10, TypeScript is going to be able to infer all of these generic arguments, but you can always pass them explicitly if you want. And one of the maddening things about the Swift language, unless it's changed in the last few months, it doesn't let you explicitly pass generic arguments. It forces you to always set things up so that they can be inferred, which I always hated. But Swift is a pretty cool language other than that. Okay, I am going to move on to the next part of the generics that I want to talk about. All right. So I have set up a little bit of boilerplate. So imagine that we want to write up that we're building some sort of very primitive music playing app. And we have this root type called catalog item. And then there's some types that inherit from catalog item. We've got an art, so catalog item has an ID, it has a URL to whatever thing that you're looking at, and it's got a big bag of metadata. And then we've got artist that extends from catalog item and it adds a name, the name of the artist. We've got album that inherits from catalog item and it adds a name again and a track count, because why not? And then a song is the same idea. It adds a name and it adds a duration for the song. And I just want to pause here for one moment. If you see we're using interfaces, I could have just as easily used types, which you'll see more often. Types are much more common. Type artist2 equals. So this is exactly the same. I suspect the interface syntax might be a little bit simpler than having to mess around with these type intersections. If you like this much better, I'm sorry, they're the same either way, it doesn't matter. I chose this because I think it'll be a little bit simpler to look at, a little more obvious to look at. You have the nice extends keyword. The point to get across is it doesn't make a difference either way. Yeah, we're not going to have the type versus interface debate. It doesn't matter 99 times out of 100. Excuse me. All right. So we've got these types set up. I use type almost always. I almost never use interface. I just used interface here. I think it's a little bit clearer for the purposes of this demo. Anyway, and I've set up this artist object. It doesn't really have anything interesting. Let's say Taylor Swift, whatever. All right, so the point here that I'm getting at, let's say we've got some async function, and I want you to, any music service that you use, whatever you're looking at, they almost always show like similar items. So like if you're looking at an artist, it'll almost always show you, hey, you might also like these other artists. If you're looking at an album, it'll often somehow show you other similar albums and so on. And so I want to think about what a function like that might look like. It's an async function that takes an item and it returns an array of similar items of the same type. So if you were to pass Taylor Swift in here, you might get like Sarah Bareilles, Ariana Grande back. If you were to pass in a particular album, you might get other similar albums and so on. And in real life, this would hit some sort of backend service. For now, we're just going to put a little delay in to make sure that it's async. And then we're just going to return the same item back. Because the purpose isn't to actually find similar items. I just want to talk about what the types would look like. So what type are we going to pass in for unknown instead of unknown, and then the unknown array? And you've got these nice types up here. So you might think, well, okay, I'll pass in catalog item. And if you see below here, I am passing, I'm calling it, and I'm calling it with some artist, and TypeScript's not yelling at me. So this works for now. So it's taking in an item of that, and then it's returning an array of catalog item, and I'm using it with artist, and that works just fine. The problem is if you look at what X is, it has inferred catalog item, which kind of makes sense, but it's also not what we want. So if we were to look at what we get back here, we know they're artists because we passed an artist in, and our backend service looked up similar artists, and we really forced the issue by returning the same exact item back. But if we start looking at it's async, so it's a promise. We look at what we're getting back here. There's no name. because this is typed as catalog item instead of artist. So this is the generic section, so you probably can see where this is going. Let's make a copy of this. We'll say that this is the old one. And now let's make this a generic function. We'll say this takes in a type T. Item is type T. Returns that. And now if we look at this X type, it is in fact an array of artists. I'm not going to do the promise.resolve and all that. You can see they're artists. The problem is, what if we just pass junk into this function? TypeScript's like, cool, you passed a number, T is now a number, so this is going to be an array of numbers. We don't want that. We want the best of both worlds. We want T to still be generic so that we don't have that type erasure that we had before. We don't want to erase the type we passed in. We want to get back the same type, but we also want to limit it to catalog item. And TypeScript lets you do that. TypeScript lets you say, all right, this is a type parameter, but it's not freewheeling here. We're going to say it has to extend from catalog item. And this is the same extends that we used up here, but this would work just as well if these were types instead of interfaces. It makes no difference. The same extends keyword is being used two different places. We're going to see it again later if we get to conditional types. So this fixes the problem here. Now TypeScript is like, you cannot just pass a number in. That's not valid argument of type number, not assignable to parameter of type catalog item. And that wraps up what I was wanting to talk about for generics. And we will move on in a minute. But I want to give you a chance to ask questions. Let me check the chat. If I recall correctly, type 1 and type 2 is a bit less performant at compile time than interface, extends interface, but also interfaces can bite you with interface merging. So types are probably safer. That's interesting. I can't make any comments about which is more performant. That might be true. Interface merging is a good point. That's something you might want. If you're building a library, you might lean on interface merging. I'm not going to talk about that here. It's usually only relevant for TypeScript libraries. And as a user of a library, you might want interface merging if you want to modify someone else's interface. So like if you import some React types and you need to modify something, you could potentially do that if they used an interface and gave that to you. All right. So next section I want to talk about is type unions. And I have got a few types whipped up. We've got a type cat. It's got a name, whiskers, and a feline breed. We've got a type dog, name. It's got an obedient Boolean and a canine breed. And let's say that we say let animal, it's a cat or a dog type union. And here's where it gets weird. I'm just going to say null as any, just ignore that. I just want TypeScript to treat this as a cat or dog. If I leave that off, TypeScript will scream at me if I do animal dot because it's not initialized. So I'm going to just initialize it with null. And we're just going to pretend that this is a value. We're not running this code. This is what I want you to focus on, the left hand of this. So we've declared animal and it's a cat or a dog. So I've seen experienced engineers complain about this on Twitter. They say, all right, well, animal is a cat or a dog, so I want to say animal dot, and I should get all these properties. I should get name, whiskers, feline breed, name, obedient, canine breed. I should get them all, but when they hit dot, all they get is name. They're like, hey, this is terrible. This is broken, and this is stupid, and they designed it wrong. They didn't design it wrong. The people who designed TypeScript did an amazing job, and this is by design. And the reason for that is related to the structural typing that I mentioned at the very, very beginning. And to sort of show this a little bit better, I have got a few slides, 4 of them. This won't take long. We're going to get back to the coding real quick. 4 slides, and this first one is one of them, so we're already down to 3 left. TypeScript is structurally typed. I covered this already. A variable of type foo means the variable has the same shape as foo. It means nothing more, nothing less. So how does that relate to unions and intersections? This is the same code we just saw, similar. Cat or dog is a cat or a dog. What does that mean? So 4 slides, really, it's just the last one. You have to think about these things in terms of a Venn diagram. So the left circle, think about that as all the different types of cats there can be. And the right circle is all the various types of dog there can be. And I mean, this intersection might really be empty in real life. I mean, it would be a poor, horrible, deformed creature that's a cat and a dog. So that may not have any meaning. But if you were to declare a variable of cat and dog, it's both a cat, got everything that makes a cat, and also a dog at the same time, which is kind of terrifying. But the cat or dog, it's both. Or either. It's either a dog, anything that can be a dog, anything that could be a cat, either way. And so it still may not be clear what the point is. So you're saying, okay, well, it's a cat or a dog. That's what I thought. So why can't I reference any of the cat properties or any of the dog properties? The answer is because TypeScript doesn't know. TypeScript's like, well, I can't let you reference feline breed or whiskers because what if it's a dog? Then those things are going to be undefined, and I'm not going to let you reference stuff that doesn't even exist on this object. And you can't reference the dog stuff because it could be a cat. And then there's not going to be, if it's a cat, then there's not any of the dog stuff. Incidentally, you say deformed. If you do that, well, now it's a cat and a dog. So it's both. So now TypeScript is like, well, okay, it's got everything. Now I can access all the properties because it's a type intersection. It's both. It has everything that makes a cat and everything that makes a dog. So in that case, TypeScript will let you reference everything. So when you do a type intersection, you get a union of all the properties. And when you do a type union, you get an intersection of all the properties. Cool, neat. Some weird math words that we use. How do you actually use this thing is what you care about, right? So there are 4 different ways to narrow a union down. See how we have some type unioned with another type? And TypeScript is like, well, I don't know which it is, so I'm going to only let you mess with whatever happens to be on both types. There's 4 different ways to narrow that union down so that you can actually do useful things with it. The first one I'm going to show you is really, really weird. And you're not going to see it that often. But I want to just prove to you that this is a JavaScript. This is an old school JavaScript thing that some of you may not even know about. Unless you're old like me and you've been doing this for too long. This is JS Fiddle. Okay, this is just plain JavaScript. There's no TypeScript here. This is just a plain JavaScript sandbox. So let's say you want to test whether there's an A property, and there's like object.has property or object.has. There's all these modern things that are now built into JavaScript. But back in the old days, one of the ways to do this was if we write a string and we type perfectly the property name, we could use the in keyword like that. We could say, is A in this object? And that is just plain vanilla JavaScript. And it says true. Oh, let me bump this up a little bit. We've got a plain object. It's got one property. We can say, hey, is A in this object? And TypeScript will say, or JavaScript will say, yeah, it sure is. We say A, it's going to give us false. You say, what about junk on the prototype chain? Oh, it'll check that too. It'll run all the way up the prototype chain and just look for any property that happens to match whatever string you type in. Don't fat finger it though. You get no help from anybody. It's just a string. JavaScript will be like, oh, false. So what does it have to do with us? It turns out that TypeScript is aware of that in keyword. Of course, you can use it. Like anything in JavaScript, you can use in TypeScript with a few very, very narrow, bizarre exceptions. But you can, of course, say if whiskers, type it correctly, because no one's going to help you if you don't, in animal. So that's, of course, going to be valid. You can, of course, type that. That's JavaScript. But the cool thing is TypeScript will look at that, and TypeScript will be like, oh, well, if this whiskers property is in this object, well, it's got to be a cat then. And inside of that if block, TypeScript will let you mess with all the cat properties. And not only that, TypeScript's doubly smart. When you go into the else, whoops, it's like, okay, well, in the else, it's a dog. So inside of this if, it was a cat, obviously. Else, well, now it's got to be a dog. That's all it's left. This might seem like a really cool solution. It's not very scalable. This just happened to work well for us because we only had 2 types and they were very simple types, and there just happened to be one type that existed in exactly one of the types. As you start adding more types, more complicated types, you're going to have a lot of overlap between the types. You might have the same property that exists in more than one type. And then when that starts to happen, it's going to be harder and harder to find exactly one property that is uniquely inside of one type. And not only that, if you fat finger this, if you say whiskers, if you say waskers with an O, first of all, that's still valid. And TypeScript's going to be doubly weird. It's going to be like, hey, I'm going to be helpful. Look what it gives you. It gives you the same name as before, because name is always there. And it's going to be like, well, you told me there's a waskers in there, so there's got to be a waskers. And what type is that? Well, it's unknown. TypeScript's like, well, it's there. I have no idea what it is, but you just told me it's there. And that's because, I mean, we're just plain old typing properties into strings. I will say this is a very, very useful trick to know. It won't come up very often, but when it does, you can be the hero on your team and just pull this trick out if you need to narrow types down in a union when you can't modify those types. If you need to deal with a union and you either can't modify the types or it would just be too much work, well, pull this trick out. It might save the day. Okay. So what's the grown-up way to do this? We don't want to type property names. It's going to often be the case that we can't do that. So remember, the problem with this is that it's going to be hard for us to assume that there's always one property in each type that uniquely identifies that type. What if we just force the issue? What if we do this? So the first thing I want to note, the screaming case, it means nothing. It's just a regular old property as far as TypeScript is concerned. You can type it however you want. You can call it whatever you want. You can call it tag. You can call it tag. I don't care. Underscore tag. It doesn't matter. It's common to use screaming case for type discriminators, which is what I'm about to explain. This is not an object property. This is a property on a type. And so if you look at the other properties on this type, we have string, number, string. This is not a string. This is a literal type value. So I'm saying that this type cat has a property on it called type uppercase, and the type of that is the string cat in all caps. Nothing more, nothing less. Not lowercase cat, not mixed case cat, just cat. And we'll do the same thing for dog. And so now, when we say animal dot, we've now got the second property that's available, and it's either a cat or a dog, nothing else. And that means we can now say if animal dot, and now we can check this type, and now we actually get autocomplete. And now if we fat finger something, TypeScript can be like, yeah, that is not valid, bro. This type, it cannot be dog too. It has to be cat or dog. And now we've narrowed it down to a dog like before. And just like before, if we go into the else, it's a cat in the else. This does make it a slightly less convenient to use these types. Now, if you want to create a cat, you now have to provide all of these properties, and you have to provide not valid. TypeScript yelling at you. You need to provide the type cat. So if you are ever dealing with this kind of stuff, helper functions can help. Create cat. Sometimes providing manual return types is a good thing. Some people disagree with that. If I take this off, I'm trying to have a function that creates a cat. TypeScript's like, whatever, sounds good. You say create cat, it returns whatever this is. Just declare it. Say, hey, this function returns a cat. And now TypeScript's going to check you right here, right now. If you screw up, you'll see the error right here. You won't see it 5 files over where you try to take the result of this and pass it all through your application and get a weird error. The error's right here. And the problem is I need to type, and it's cat. So a little helper function can help you deal with these type discriminators to prevent boilerplate from creeping up. Let me check my notes, make sure I'm not leaving anything out. Okay, so let's get a little bit weird. Let's create a baffling, annoying error. Let's say that we create this cat object. Notice that I have not typed it, right? This is just an object that exists. And it's got everything that makes a cat, and it is a valid cat. Okay, TypeScript is not yelling at me. Just ignore those yellow squigglies. Okay, just make that go away. So this is valid, but let's remove the variable type of it. So it's still the same object that it was, but I've removed the cat declaration. And now let's come down here and let's say that cat2 is a cat. And let's assign it to the original cat that we just created. So TypeScript's yelling at us. So I told you that TypeScript was structurally typed. And I told you that all that matters is that the structure matches. And it seems like TypeScript is making a liar out of me. And if we look at the error message, so my big lesson to all of you is always read the TypeScript error messages. Don't just let your eyes glaze over. Sometimes they'll be really big. Skip the huge chunk in the middle, read the beginning and then skip to the very end. And it'll always, almost always, hopefully always end with something like this. Type, feline breed string, name string, whiskers, number, type string is not assignable to type cat. And here it's just giving you the answer. Types of property type are incompatible. Type string is not assignable to type cat. And so the problem is, if we leave off the type declaration, TypeScript will synthesize a type for us. And the type that it synthesized is string, this type. But we don't want string. We want a literal cat. And so when we declared this as cat, TypeScript will cut you a break. TypeScript's going to be like, okay, you're declaring it as a cat. You put the right screaming thing on there. I'm just going to treat it as a literal type. But when you don't do that, TypeScript has no idea. It doesn't know that you want to treat this cat as a literal type. Just because it's uppercase, it's never going to assume that. Just like this name it's going to assume that it's a string that happens to be muffin. So how do you tell TypeScript, no, this is actually a literal type that will never change? As const. Oh, and let me just a little JavaScript refresher. Using const here will not save you. Hopefully everyone knows that. When you declare a variable as const, it just means that the variable itself cannot be reassigned. It doesn't mean the contents are constant. So the solution here is we say as const. So now that says that this property is constant. It's immutable, cannot be changed, and now TypeScript will accept what you wrote. And incidentally, you can do that to the entire object if you want, if you need to. Now the whole object is immutable, and now feline breed is empty, name is a constant, read-only string of muffin, read-only, blah, blah, blah. All right. All right. I told you there was 4 ways to narrow types in a union. The first one was using that crazy in operator from TypeScript. The second is using a type discriminator. By the way, that's why they call these discriminated unions. This is how you discriminate between different types. TypeScript doesn't know if it's a cat or a dog, so we use this type property to discriminate between the one or the other. What if we have a union of primitive types? Let's say we do let string or number equal, oops, give it a type, string or number, f.random. If we get a small random number today, we're going to assign it a string, else we're going to assign it a number. So truly, TypeScript has no idea. It could be a string or a number, depending on which millisecond of the day we run this. And so if we say that dot, TypeScript will let us mess with the things that are in both a string or a number. I'm going to go back to JavaScript for a second. In JavaScript, you can say type of. Yes. That's about log type of n, and I'm going to create a class. And we say let instance equal new C. I'll get that to in a second. So if I run this, clear the thing out. If I run this, the first one gives me back string, second one gives me back number, and now you might be like, oh, cool. Console.log instance, that's going to give me back C, right? Because instance is an instance of C, so the type is C. Now it's just going to give you object. Oh, wait. Oh, never mind. Type of instance. I'll lose my mind. Now, if I run it, it's just going to give you back object. So this is a little bit of JavaScript trivia. In the old days, if you did type of something, there was exactly 6 values that it could possibly only ever give you back. Number, string, Boolean, function, undefined, object. And that's it. And then in 2015, they added a 7th one, which is symbol. They added the symbol type to JavaScript that will give you symbol. And then a few years ago, they added an 8th type, which is big int. And that's all there is. So why am I talking about any of this? What does this matter? Well, just like the in keyword that we talked about before, it turns out that TypeScript is wired up to be aware of the type of keyword. So if we say type of srn equals, look at that, I even get autocomplete. Here are the 8 values that I mentioned. The originals, Boolean, number, string, function, object, undefined. Symbol was added in 2015. Big int was added a few years ago. So this one's only going to be a string or a number. Let's say it's a string this time. And now srn, it's giving me all the string properties. Else, srn, and now it gives me all the number properties. That's 3. There's one more way to differentiate. So first we started with TypeScript types, and we saw the in keyword or manually adding a type discriminator. Then we said, hey, what if we have a union of primitive types? Well, you can use type of. Now it gets really bespoke, but again, this is a useful thing to just know. What if you have a union of class types? Classes aren't used too commonly, but they have their place. Let's say we have a class A. Say we have a class B. These classes do not inherit from each other. Common number. Math.rent. So this is one reason I like using classes for some things, as we'll see in a second. When you declare something as a class, well, now you have a free factory function that's built for you. If you just did a type, you can't just do new on a type. You can only do that with the class. Let A or B, and we're going to say that this is a union of classes. So, like before, you say A or B, dot, all you have is common, because TypeScript doesn't know if it's an A or a B. You know this already. Back to JavaScript. One more weird thing in JavaScript to show you. So I'm going to paste these classes into JavaScript. Got to get rid of all the types because this is JavaScript now. JavaScript doesn't do types. And that, I get rid of all the good. Okay. Boy, the syntax highlighting is horrible here. Let's do this. All right, instance of is the point. You can say a instance of the class A, like that. And if I run that, I get true. If I test it against B, I get false. So instance of lets you check if A is an instance of some class. Does it work with inherited classes? Yes. If you say, we'll just briefly say B extends A, and now let's say let X equal new B. Is X an instance of A? Yes. If they inherit, inheritance counts. You know where I'm headed with this. TypeScript is aware of the instance of operator. You can say is A or B instance of A. And now you can say A or B, and you get all the A stuff. Else A or B, you get all B stuff. And those are the 4 ways that you can narrow down type unions. Is using as more like an anti-pattern? If I was more certain it is a string, for example, could I have said that's it? As is a typecast. It's very, very dangerous to use. It has its place, but make sure that you're sure, because if you say as and you're wrong, things will break at runtime. Try to narrow things down using one of these methods so that you're a lot safer. That's my advice. But as has its place. I even used it up here, but it was for sort of bad reasons, just to shut TypeScript up so we could focus on other things. All right. Cool. And now, sort of the fun part of this, I've got sort of a mishmash of advanced topics on TypeScript that I want to get into. And I've got a few slides, again, that I want to go through really quickly. They'll open. And it's a great time to ask questions, of course. Ooh, it's slow. Come on, Google Drive. There we go. 7 slides, won't take long. And this is one of them as before. Advanced stuff. So variance. This is one of those computer science topics. It exists in lots of languages, including TypeScript. It's very, very useful to use very rarely, but it comes in handy to understand this. At its most basic, variance means that a certain type was specified, like X, but you provided a different type. And sometimes that's fine. I'm going to use classes to talk about this, but it has nothing to do with classes. TypeScript is structurally typed, If you prefer type over class or interface, that's fine. This doesn't matter. Classes let me very clearly and obviously show how types relate, which is why I'm going to use classes for this. So types of variance. Covariance means you provided something more specific than what was asked for. You asked for a shape, and I give you a circle, and that's fine because a circle is a kind of shape. Contravariance is the weird one. That means I provide something less specific than what you asked for. You asked for a circle, and I gave you a shape, which seems wrong, but under weird circumstances, it's actually okay. And we'll look at those. Variables and function arguments are covariant. So here we go. We've got this class and a circle that extends the shape. I create a circle, create a shape. Here's a function that takes a shape. You can call the function and pass in circle, and that's fine. And we sort of intuitively understand that. Structural typing is still true. Don't let the class thing fool you, like I just said. Here's a little bit of trivia that one of the TypeScript core members taught me. TypeScript is extremely structurally typed. If you have a class that extends another class, TypeScript doesn't even look at the extends clause ever, other than just to see, it'll look at the extends clause just to see the structure of whatever object that class creates. But if one class extends another class, but it doesn't actually add anything, those classes are going to be bivariant, which means you can provide one for the other anytime, always, even going the other way. If I say class circle extends shape, but I don't add the radius, I can provide a shape where a circle was asked for or a circle where a shape was asked for anytime, because all TypeScript cares about is the structure. I hope classes make this easier to follow. If you hate classes, that's fine. You can hate them. Everything I'm saying applies to non-classes. What about contravariance? That applies when you have variables of a function type. And I'm going to just show you that shortly with code and explain it. And then at the very end, if there's time, we're going to talk about conditional types, which are really, really neat. Okay. All right, I can close the fiddle. Done with it. All right. Not to beat a dead horse, but these classes I'm going to be showing you, it's the same thing as this. If you really hate this for some reason, everything I'm going to show you is the same, and this is how you would write it with types. The one downside is you can't say new shape 2, and that sucks. But I can say new shape because that's what a class gives you. A class gives you a synthesized factory function for free. So it's going to be useful for me. So that's why I'm using classes. Okay. I've got a shape class and I've got a circle class that extends shape. Let me look up the notes, make sure I cover what I want to cover. So far, so good. You can create a circle, create a shape. I'm giving these types just to be obvious and boring. In real life, you'd probably leave them off. Shape equals circle. That's fine. Shape is just a generic variable that holds some kind of shape. Well, a circle is a shape. So you can assign it that way. You can't do the reverse. Circle is typed to specifically be a circle, so you can't assign it the other way. You can call draw. It's typed to take a circle or to take the shape. You can pass something more specific in. This is kind of obvious stuff. People are going to know this intuitively. Usually you're taking a function, you have a function that takes a generic shape. You can pass something more specific. This part is not too crazy. Let's talk about the weird parts of this. Let's say we have a type called draw shape function. This is a type. And it returns void. And we'll do the same thing for a circle. Product factoring of that circle. There we go. And now let's actually let's create a variable of type draw shape. And it takes in a shape. And I'm gonna type it explicitly, even though I don't have to. And I'll do the same thing over here. And now I have access to all the circle stuff. So I can say, all right, you drew the circle, we'll log the name and the radius. Okay. So circle is more specific form of shape. So I should be able to take this draw shape and I can assign it, it's a shape, so I can assign it to something more specific, and that's fine, right? I can say draw a circle. And TypeScript yells at me. That's weird. That's the opposite of what I expected. What about the reverse? That should be invalid, right? Draw a circle. I certainly can't assign a shape to a circle, but in this case, it's fine. And so thinking about this the right way can really help to see what's going on. So draw shape isn't a shape. It's a function that takes a shape in. Or to put it another way, it's a function that works with any shape you can possibly think of. So if you are the holder of this function, this variable called draw shape, you have an expectation that you can pass any shape that you can possibly think of into it and it should work. And that's why this breaks. You say, hey, this function has to work with any shape, but you gave me this much more narrow, much less useful function that only works with circles. And that's why it breaks. I want a function that works with any shape, but you assigned it a function that only works with circles. And that's why TypeScript is screaming at me here. Over here, it's the reverse. I said, hey, I just need a very limited function that only works with circles. And you gave me a function that works with any shape in the world. So that's much more than I asked for. And so TypeScript is happy with that. Now, when you start calling this, it's going to be a much less useful implementation because I'm assigning it to something that only uses the shape stuff, but that's fine. That's not, well, maybe it is my problem, but I asked for a function that works with only circles, and you gave me something much broader that works with any shape in the world. I will pause here for a minute, get some coffee and water. And I know this is kind of, we're not going to end on this, but this is a good time to ask a question if you have one. This is the weird stuff. We're going to go from the weird stuff to the fun stuff right now, but I wanted to cover this because it's a useful thing to understand.
With function overloading and type overloading on functions, is this kind of where we're starting to head with this, or I don't want to jump the
That's
gun on you?
totally different. And that is a crazy thing that TypeScript lets you do. I almost never use it. I think it's like you can do or you can overload it where S is now a number and we'll keep A as a number and we'll create one more overload where S is a Boolean. This S parameter can be all sorts of things. And then you have to actually make it come true.
Got it. So you would use effectively type narrowing in this overload
Yeah.
situation? Because I'm looking at your draws and I'm like, they're very similar. Wouldn't you just want to write one function for both of those? And so using type narrowing would let us do that effectively.
Say the last part again.
So if I wanted to, instead of having a draw shape, draw circle function, because they're very similar in structure and because of the covariance there, like couldn't we do just an overloaded draw function that took in both the draw shape and the draw circle, but then used our type narrowing to select the right kind of output, so to speak.
Yeah. Let's see.
I think you have a draw above, just FYI.
Oh, what did I do? It's weird. Oh, no. In theory, this should work. I don't know why it's not.
Well, a circle is also an instance of shape, so that's why it's not working.
No, it should give me both then.
No, because there's no else. It gives you never.
Yeah. So what did I do wrong? So, oh,
I think you got to go from more
Yeah,
specific to less
right.
specific.
Boom. That's it. Good catch. Wow. Yes. It's an instance of, yeah. So here I get rate. Yep. Oh, good catch. Thanks so much. Okay. So you have to check. So you wouldn't normally do this. You would probably rely on dynamic dispatch but polymorphism. But if you really wanted to, you could. A lot of foot guns. Make sure you check the more narrow thing first, and then you can rely on the less narrow things. I'll be honest, I have never used function overloading in TypeScript. I'm sure there's useful use cases. It doesn't ever come up for me, but it is a tool to have in your. I had to even take a lucky guess on what the syntax was.
I usually see it in libraries like Apollo and React Query and those types of things. But you had such a good contrived example to ask about it. I had to ask.
Yeah, good stuff. All right, let's talk about conditional types. Conditional types let you ask questions about a type. So let's get the most contrived, most useless thing we can imagine. Okay, so I have to look at my notes. This is such a useless thing to do. All right, so this is silly, but look, array of unknown. Here's that extends keyword. I promised we'd see it again. Does an array of whatever extend object? If so, true, else false. We get true. Okay, so that's the first step. That's step 0. TypeScript lets us throw a ternary in, and it has to be a ternary. You cannot use if else. Some people hate that. Whatever. Some type extends, another type, ternary, true, else, something else. Okay, cool. Let's make it slightly less useless. Let's say type array of what, and we'll make it a generic type of t equals t extends array of, it'd be nice if I could just say u here and then just grab the u out there, else never. So TypeScript's yelling at me. We're so close to correct syntax. So this is a type array of what? It takes a t. Does t extend an array of something? Grab that something. Well, we just need one keyword, and it's infer. And now it works. So we can say, hey, array of what? T extends an array of something. Give me that something. Never. Let's use it. Let's say type number, array of what? Number array. And now, there's already a number. My number. And now my number is number. What we have now isn't perfect, though. What if we pass something invalid? We get never, and I guess that's fine, but I'd rather get an error here. Like, what if we wanted to force you to only use this type with arrays and just error out? Well, remember, we can limit, we can narrow what types this generic can be used with. And when we do that, this now errors out like we'd like. Let me check the chat real quick. Cool. All right. Let's go deeper. Let's say we wanted to take, so with conditional types, this is sort of the kind of thing that you're going to do with it. Conditional types are really, really great at letting you sort of do meta programming on other types, sort of chop apart and break apart and sniff into types and pull pieces out. And let's really lean on that and see some of the things that we can do with that. Let's say type, I'm going to call it get return type. Just give me 1 second, make sure that's what's your problem. You've got identified. Export default to null. Okay, cool. Yeah, now it's the warnings. I gotta shut that off next time I do this. All right, so let's say we want to have a type that gets the return type off of some function type. So like before, if I can type, it's going to take a type in. And now we will say T extends some function that returns infer U. If that is it, else never. And now let's say we have a type called get circle. And now circle, hopefully, get return type of get circle, and it works. Circle, but hey, what if oh, it still works because of contravariance. Okay, well, the idiomatic way to do this is, well, it's a function that takes any number of arguments. Still works. I guess you don't even need to do that. That's fine. Okay. Again, that's contravariance. I asked for a function that, well, I'm not going to get into that. Okay. Unfortunately, like before, stop it. What if I just pass in a non-function type? Still works. It gives me never. Like before, we can narrow this to extends args any like that. And now it errors out. I'm going to do one more, and I know people know where this is headed. You're not ever going to have to write these particular things. But let's write a get parameters, which will also let us look at another interesting thing. I'm going to leave this narrowing thing. It's going to only work with functions that take args and return something. Except now I'm going to get rid of the U here, and I'm going to say this function returns anything. Get parameters. T is a function, and we'll say T extends, and this big parameter pack that can be anything, infer U, return U, else never. And let's create some function. And now if we look at params, we have got a tuple type. Turns a number and a number. Let's make that string just to get a little more interesting. And so what if we wanted to get the first parameter of this function? Well, that's one thing I didn't cover before. Type thing. Does anybody know? What if I want to get the type of something that's already declared? Obviously, type of A is just string, but I don't want to write string. I want to just say property A of thing. If you're a C++ or a Rust developer, you might think like thing : A. TypeScript is having none of that. Even if you type it right, TypeScript's having none of that. If you're a JavaScript developer, which we all are, you might think thing.a is right, but it turns out that's old gross namespace syntax from TypeScript. It turns out TypeScript wants you to use square brackets like that and use a string. And now if we do that, we get type of A is a string. That's usually in like the intro section of this that I skipped. Works for arrays too, which is what a tuple is. So this is params is an array number string. I can just do that. Use number for the array. And now params is a number. I'll call it something better. First param, that. Second param is a string. So property access is something you can do on types, and it even works on array types, and you can pass in the number of the index you want. Okay, I'm sure a number of you already know this. You don't actually have to write this out because TypeScript already has a parameters helper type, utility type, and it also has a return type, utility type. And what's especially cool in VS Code, if you press Command click, boom, you can actually see these types declared in all their glory. And you can just snoop through here. There's tons and tons and tons of stuff. You can see how they're implemented. You can see how the sausage is made. Lots of cool stuff in here. Okay. Really quick. This is where I just sort of let TypeScript show off a little bit. And I just show some of the really neat things that TypeScript is capable of. I got about 10 minutes left. I'm going to get myself a clean slate here. I wrote this for render ATL. Correct life choices. Tracy's in Atlanta, so I'm just going to leave this here. Correct life choices, conference, render ATL. I stand by that. Best conference you can ever go to. I hope to see you guys there next year. City, Atlanta, language, TypeScript. These are correct life choices. This is a type. It's not a variable. These are all literal types. Let X, correct life choices. TypeScript's going to be very particular about what you assign. You can only assign Atlanta. These are literal types. Whatever. Okay. Let's talk about map types. You can create a type where the keys are the keys of another type in key of, like that. So let's imagine we make this copy and we're going to say, hey, this is an object. All of the key values are the keys in key of this other type, and they're all strings now. Let X. And now TypeScript is going to be like, well, city is any string. So we made this a less specific type. Well, what if we want to just be faithful to what was there before? Well, I just showed you. You can use those same property access types or whatever you call them. And now all we've done here is we've created a clone of another type with way more effort than we needed to. We could have just said equals correct life choices and called it a day. But this is useful for other things. So I wanted to start this way. This is a very elaborate way you can just make a copy of a type. If you really just want a copy of a type, just make a copy. That's all you have to do. Okay, you can clone a type like that. But this lets us do some really interesting stuff. So what if I want to take this type and instead of just being those properties, what if I want to make it be a function that returns that same type? And now instead of returning that value, What if I want to make that key map to a function that returns that? So now if I say let x is that, look, they're now functions. Conference is a function instead of a value. Why are you complaining? Oh, it's not assigned. Just to make TypeScript shut up. Okay, so now I can call the function of that. But this doesn't really match, right? It's called conference. So if we see a property of type of, if we see a property named conference, we expect it to be a string, not a function that returns a string, right? Let's make another copy of this. Getters, better name. So it turns out that TypeScript it lets you alias these properties. You can actually throw a literal string in here like that. And now we've taken that key name and we can just ram it into a template string and TypeScript will respect that. These are called string literal types, I think. I should have looked that up before I did this. Sorry about that. Now, if I use that type, now these properties are called get city, get conference, get language. Better, the casing is messed up though, right? We want the city to be capitalized, conference to be capitalized, and that. Better name 2. Remember all those utility types that I showed you? All these crazy useful types, uppercase. Look at that. Hey, there are types that will mess with strings. And there's not even, this is just intrinsic. TypeScript's like, hey, you can't write this in TypeScript. We're just going to ship it. It works. Don't even, you can't do this. Watch this. Capitalize. Okay. And now, when I do this, now I can do x dot, and look, it changed the casing of these. Get city, and now city has an uppercase. It's a function that returns Atlanta. And with that, and this rabbit hole goes even deeper, you can do really gross things. Here, I'm just gonna, these are some notes that I had. If this were a 4-hour conference, you can do like routing with this, and you can like pluck paths, and you can say t extends, and you can put a string literal, and you can infer parts of that string literal. See the infer here? Put that in VS Code so you can pluck paths 4. We give it a path, and now we say t extends. And now look, I've got a template literal here. And inside of the template literal, I'm matching up the path that you passed in. And then whatever comes after the path, I can infer off of that. And I can grab just that chunk of the path, which means that well, whatever, you get the point. Suffice it to say, this is incredibly powerful. If I had more time, we'd dive into all that. Come to Render ATL. Maybe I will do the whole workshop there again next year, hopefully. All right. You guys have been a great audience. Thank you for coming out. This was a lot of fun.
Yeah, thank you, Adam. And just a reminder, everybody, Adam, where can we find you on the internet?
I am on Twitter at Adam Rackis. I'm on GitHub. I'm linked off of there. All of this code, if you go to my GitHub, there's a TypeScript workshop that I have pinned. right there. It's not really a class, but all of the code that I've been writing, you'll see like instructor reference files. That's everything I was looking at and everything I was sort of recreating. I would check it periodically, make sure I hit everything. But that's, if you are really interested in this, if you go to the advanced topics one, that's where I've got a lot of the stuff written. And there's a few exercises in there, and that's where all that gross. If you want to play with some of this stuff, you can use this as a guide, and you can sort of see where a lot of this power is. I also recommend Matt Pocock's TypeScript course. It's expensive, but if you work for a company with education budget, that's a great way to spend it. Yeah, and if anybody has questions, I'd be happy to field them.
Well, Adam, thank you so much for your time today, and we really appreciate you coming and talking to us about TypeScript. If you enjoyed this training with Adam, there are more on our YouTube at this.media. We hope you come and enjoy those in the future, and we look forward to talking to you all next time.
This program is presented by This.Labs, the framework-agnostic consulting firm helping enterprises realize their technical goals through staff augmentation, consulting, project management, on-demand subject experts, training, and other professional services. Find out more at this.labs.com.